Welcome to this explainer. Look, if you're a SaaS founder, a CTO, or an engineering leader, you already know that turning raw enterprise data into highly reliable user products is, well, it's one of the absolute hardest challenges in tech. Today, we're mapping out exactly how to architect your enterprise data to achieve true engineering velocity. And we want to do this without hitting that invisible wall where pipelines just break, identities collapse, and your teams grind to a complete halt. We're going to be drawing on some incredible insights from the trenches of enterprise architecture and modern data governance to show you the hidden systems that quietly control, well, literally everything.
Okay, let's just quickly run through our blueprint for today. We're going to cover the hidden cost of speed, dive into architecture as code, and dissect architectural debt. Then, we'll explore creating data case law, the Basecamp scaling approach, and finally, what true engineering velocity actually looks like in practice.
All right, Section 1, the hidden cost of speed, or why fast-moving projects fail. We really need to start by shattering this illusion of speed that plagues so many fast-moving data engineering projects today.
So, I've got to ask you, why do fast-moving data projects just suddenly hit an invisible wall? You've probably seen it. A team spins up a new initiative, they're absolutely flying through the setup, configuring fields in a user interface, and everything seems to be moving at lightning speed. But then, out of nowhere, environments start drifting, debugging becomes basically impossible, production behaves entirely differently from your dev environment. It feels like you were sprinting, but the reality is you were just accumulating massive amounts of debt. Moving fast by just tweaking UI configurations, it's a really dangerous trap for your platform. There is a massive difference here between an amateur approach and a true engineering mindset. When learning enterprise platforms, beginners often think schemas are just surface-level UI configurations, essentially just simple screens and forms for humans to fill out. But the deeper you go into real architecture, the more you realize the UI is only the surface. An engineering mindset recognizes that schemas are actually machine-readable JSON architecture documents meant for the platform itself. They include classes, attached field groups, identity fields, relationships, the whole shebang. It's a completely different mental model. The UI is for humans for sure, but the underlying structure is for the platform.
Moving right along to Section 2, Architecture as Code, specifically the Schema Registry. Let's zoom in on the core technical solution here. The Schema Registry completely redefines what a schema actually is. It becomes the single source of truth inside your organization. Think of it this way. If your data foundation is the language of your platform, the Schema Registry is the strict dictionary and the rulebook. It's not just some back-end database. It actually exposes a full REST API. This means literally everything you might create manually in a UI, schemas, field groups, identity descriptors, can be created programmatically. You stop thinking about configuring fields and start thinking about defining structured infrastructure engineering. It's a real game changer.
And this brings us to the philosophical anchor of this entire explainer. The Schema Registry is not storing schemas. It is enforcing the architectural rules of the entire platform. I want you to really absorb that. Without this centralized enforcement, your platform just becomes disconnected datasets with absolutely no common structure. This registry controls consistency, identity behavior, how schemas evolve, and exactly how your downstream applications behave.
All right, Section 3, the anatomy of architectural debt, the silent accumulation of failure. You see, bad architecture doesn't actually break immediately. Instead, it silently corrupts your downstream systems until it is entirely too late. When teams bypass that registry, you get these three massive delayed failures. First up, UI-only schema design. When teams create schemas manually without treating them like code, sure, initially everything works fine. But later, production drifts from dev, and nobody knows what changed. Next, you have overgrown field groups. Teams endlessly add fields into shared groups. Eventually, schemas become so bloated, governance is impossible, and downstream applications inherit massive, unnecessary complexity. And finally, identity drift. Namespaces change, fields get repurposed, and suddenly your identity graph is completely unreliable. And the scary part? These mistakes usually don't fail immediately. They fail way later when journeys go live or analytics start reporting wild inconsistencies.
So the absolutely crucial point is this. Identity architecture is one of the highest risk design decisions in your platform. Because identity fields aren't just labels, right? They tell the platform exactly how profiles should merge and which identity is primary. Once these identity rules are wrong, every single downstream system inherits those problems. You get broken stitching, duplicate customers, collapsed profiles, highly inaccurate audiences. Basically, if you get identity wrong at the registry level, everything built on top of it will crumble. Which brings us to Section 4,
creating data case law, or establishing an institutional muscle. To prevent the architectural debt we just talked about, we need to completely reframe how we view technical governance. It cannot be a point of friction. It has to be your platform's muscle.
You know how many companies struggle because every single new data project triggers the exact same exhausting debates between legal, compliance, IT, and business units? Debates that usually just end with everyone staring at each other on a Zoom call? Well, the solution is creating case law for data. By establishing standard technical policies, legal precedents, and governance rules early on, you severely reduce the need for constant debate. This transforms a chaotic scramble into a highly coordinated engineering strike. Teams have clear case law to refer to, allowing them to make decisions with absolute confidence. Well-designed governance doesn't stop momentum, guys. It actually makes rapid, repeatable innovation possible.
Section 5. The Basecamp Scaling Approach. How to scale without boiling the ocean. We know we need strict architecture and governance, but how do you actually deploy this? Because let's face it, you certainly don't summit a mountain in a single leap.
You've got to treat infrastructure governance as an iterative development process. Step 1, establish the Basecamp. Identify a very small set of highly visible, high-impact projects. Don't try to build a massive global structure before you even have experience. Step 2, test the gear in real time. Take a domain-driven approach where you activate governance and registry rules exactly where they are most needed first. Step 3, apply the 80% rule. Start with low-risk projects. Please don't wait for absolute perfection. Once a design is 80% good enough, codify it as your initial standard. And finally, step 4, scale quickly. Take the case law you just established and use it to expand to the next tier of functions. You start small, you learn fast, and you scale governance right alongside your maturity.
And finally, Section 6, True Engineering Velocity, moving at the speed of the future. Let's pull all these concepts together to see exactly how this technical execution delivers scalable velocity. It really comes down to two distinct paths you can take. If your strategy relies on disconnected UI datasets with weak governance, everyone suffers. Marketers, analysts, personalization teams, they all suffer from inaccurate audiences, broken reporting, and duplicate messaging. And the wild part is most business users won't even realize the root cause started all the way back at the schema layer. But if you build your data pipelines on a schema registry utilizing solid data case law, the downstream result is phenomenal. You get consistent environments, reliable customer journeys, and automated validation. That is exactly what empowers an enterprise to move safely and rapidly at scale. So I want to leave you with this one final thought to ponder about your own technical roadmaps. Take a really hard look at your systems today. Are your enterprise data pipelines actually built on a solid architectural registry, governed by institutional muscle? Or are they just precariously balanced on a fragile UI, waiting to silently break your downstream products? Because the difference between those two, that's the difference between constant firefighting and true engineering velocity. Thanks for watching this explainer. Keep building and keep architecting for the future.